Hey folks, welcome back. So we are going to move into mapping in this section. So let's go ahead and get right into it. So let's create a new file. We're going to grab my mapping as the name, contract.sol. Awesome. Again, I'm going to grab the same stuff from before off screen and bring it back here. So again, SPDX license MIT, Solidity Pragma, Solidity 0815 is the version, that we're going to be using here. We'll say contract, which will be my mapping contract. That will then be opened and we will talk about mapping in this section. All right. So mapping, as it were, would in syntax look like this. So mapping, which is a function of sorts, an internal function of Solidity that we can then give a key and then on the other side get a value from. And we then give it a name, and in this case we'll just, for example's sake, call it mapping. So in this case, again, we start with the mapping function, we give it a key, we then say that we want that to go to a expressed value of some sort. So in a different programming language, that would look like a dictionary inside of Python or a object inside of JavaScript. But more or less, literally all it is something that is more similar, or let me just see if I can do a comment really quick that is similar to this. So we would have, let's say, name and value. So name is the key in this case, for example, and then value is Joel, or the string version of my name inside of a programming language. So in Solidity, most of the time we're going to do this with a address as the key, or I'm sorry, address as the value sometimes, just because it's easier to keep track of key value pairs instead of trying to keep all of that inside of a array. So this is the caveat where we don't necessarily use an array in this case if we're trying to track accounts or keep track of multiple thousands of accounts, which we possibly could do if we had a very large company with crypto. But for example, if we needed to keep track of a large group of data, we wouldn't want to keep that inside of an array. We want to keep that inside of a map or a mapping structure. So something that looks like this. So I'll keep this up just for example's sake, but we necessarily won't refer back to that anymore because we're going to look at this in a Solidity type of way. So the syntax looks more like this than this. So but this is what it ends up being at the end of the day. So just so we're clear on that. All right. So enough about that. Let's go ahead and say mapping and actually create some stuff here. So mapping uint, which we will then map that to a string value. And we will say that will be public names. So each time that we create another uint or another name, we're going to basically create structure of 0 name, 1 name. So 0 Bob, 1 Ashley, something like that. From here, we'll say mapping uint for a book, which we still have to create. So we'll create that in a second. And we'll say public books. Cool. And mapping for an address. And that will be mapping uint book. public my books. Awesome. So what we're kind of going to demonstrate here is a smart contract that's going to catalog some books for some users. So it's a very small catalog, as it were, but in the swing of things, we're getting used to putting IDs with names and coinciding those books with those IDs. So let's go ahead and create the struct for the books, or the book struct. So we'll say struct book. And we'll say string is going to be equal to title, and string author here as well. And again, because we want this to be sent out with an initial value, we want to create a constructor. So we'll say constructor, which will be this guy right here. And we'll say names, or yeah, names 1 is going to be equal to Adam. Names 2 it's going to be equal to Brittany. And then names, sorry about that. Let me bring that down just a little bit. There we go. Names 3. Let's keep this in alphabetical order. And we'll say Charlie. Cool. Okay. So we have our struct, we have our mapping, we have our constructors. All we need now is functions to interact with those. So we'll need 2 functions in this case. One to add a book, and then one to coincide that book with the address or the identifier that sent the book in, basically. And we'll see how all that works. So first, let's create the function to add books. So we'll say function add book uint, which will be ID, string, memory, and title. String, memory, and author. And by the way, in case you're wondering what the underscore is symbolizing here, this is a convention just to symbolize that this is going to be inside, or a local variable inside of this function. Excuse me. We will then make this function public, though, so that we can call it, and we'll call it from inside of the contract, or that as it were, and we'll say books. Set that equal. Yeah, we want the ID here, so we want underscore ID, and we'll set that equal to book and title underscore author. Okay. And we'll say function add my book uint ID string memory title string memory and author. Yeah, okay, cool. Public my books. Yep. And we're getting that from up here, just in case anyone's wondering where that's coming from. That guy's coming from right up here. My books, and we're going to grab that by the sender, and we have some variables that are automatically given to us from Solidity that we can access through the blockchain. And one of those things is the message variable, which is going to give us values of when something is sent or a transaction has been sent. And in this case, we're going to grab the sender of that transaction. We're then going to ask for the ID, and we'll we'll set that equal to a book, and we'll give it title underscore author. Awesome. So understanding how these things here are working, and let's break this down a little bit. So if you take a look back at line 13, we specified that we wanted to create a mapping for a integer or an unsigned integer, which could be 0 through whatever, as long as it doesn't end, or as long as it's not negative, and then map that to a book. So in this case, we wanted to do this. So we wanted something like 0, and then John. Well, let's do. I'm a Marvel fan, so I'll just do Kang Dynasty. Let's do Kang. Let's just do Kang. And what else? We wanted that to have boom, Kang, and Marvel. Yeah, something like that. So what we're saying here is we want a uint to be the ID of the book, and then here we're just going to give it a title, in this case an author. So in this case, Kang is a title, Marvel is the author. Similar down here, we're going to do the same thing. We're going to take all of this information, but in this case, we're then going to attach it to a address. So it's going to look more like this. So we'll say, and I'm just going to grab an address from off screen really quickly. So please bear with me. There we go. So we would say the address here is going to be mapped to this value here. So this, all this goodness is going to get mapped here. So now what we can easily distinguish is who owns this book. And more specifically, what books do they own altogether? Because if we take a look at how this is structured, we can own multiple books, in this case, multiple comics, over time. So let's say this is a collection of NFTs, for example. We can put all that information inside of this mapping and keep track of, based on this address, who owns these books. And we can just kind of go right on down their catalog. So we'll see that in full action once we actually deploy this, but I just wanted to give a little credence to what this will look like. So just as you're looking at these functions, it's not completely weird or foreign to the naked eye. So let's go ahead and compile these down and see what these functions really look like on the blockchain in the next step. So we go ahead and do this. So we'll compile and compile down. I think I got a, yep, I do. I missed a semicolon. So let me go ahead and get that in there. Semicolon in, and we should be good now. Awesome. We'll go ahead and look at the rest of the values here. So I'll clean slate this guy. Still, everything else is the same. My mapping is the contract. Let's go ahead and deploy that. We'll scroll down a little bit and we'll get the values for add book, add my book, books, my books, and names. Remember, add book and add my book, those are the values that we created. So add my book and add book right there. So notice the difference in color. Then from here, we'll let's add a book. So let's do 0 and what does that want me to do? Comma separated. Okay, so 0. I'll just do, yeah, the King example. So Kang Marvel. We'll go ahead and add that book. We got that successfully in there. We can verify that if we go to books and look inside of books. So we'll say, give me the first value inside of books. So that should give me string title Kang and string author Marvel. So now if we want to associate this book with a user, we'll want to first give that, we'll go ahead and send that value out in a second. So let's say we want, let's say, let's do same example. So Kang and Marvel, and we'll go ahead and add a book. Got a successful message here, and we can go ahead and look at the my books struct. So or the my books getter, I should say. I'm sorry about that, not struct. It's not to confuse anyone. So if we go ahead and say my books, we should, oops, I didn't give it an address. Let me do that. Let's say, what address should that have been? Should be this guy right here, I think. Oh, no. Let's give it an address. Wait. Okay, there we go. Okay, sorry about that. So let's go ahead and give it an address. So in order to get that address from this account here, we'll want to copy that. So we'll click on this account clipboard icon here. We'll copy that and then bring it down here. Just go ahead and Control V that bad boy right in there, and then comma and 0, and that should give us back Kang and Marvel again. So similar information from before. Let's add another book. So let's do 1, and let's do Doctor Strange Marvel still. We'll say cool. We want to add another book, and we want to get a different book this time. So still same address, but different value for the book. So we'll say 1 this time and add or grab my books. So again, this is the same address that we were moving with before. So we got that from up here, this guy right here. And what we're now asking for is the second value for the my books mapping. So in this case, 1, because that's a indexable value. So 0, starting at 0, next position over would be 1. So that should give us Doctor Strange and Marvel. Awesome. And we can also do the names struct. We shouldn't have anything in there though, or names mapping. Keep saying struct, so I don't mean to say struct, but there's nothing in there because we never added anything to names. So, but we did add things to add book, or add things to the book catalog, and then selected that based on the address that we were looking for. So if we wanted to test to see how this is all working out, we should be able to grab a different address from up here. So if we say we want a different account, I'll just grab the second account out of this drop down menu. That should change the account. So we'll see 100 ether here. I'll copy this right there, and then we'll bring this on down, and I'll just paste that right on in here and Control V. Now what we should see is an error that comes up over here. So now we get, or not necessarily an error, but just a blank value. So it would necessarily be a logical error at that point. So we don't have any values for this user. or this account has no values at all. So that could, if we were writing this as a smart contract and that was the return, if it was empty or something like that, then we could say, hey, you don't have an account, please make an account, or something of that effect. But hopefully you can kind of see how the structure of mapping works, and the power that you can wield when using it correctly. In the next section, we're going to talk about how to control all these things, and control the input and output of if statements, and how do we use those types of things to say, hey, if this happens, then we want this to happen, and vice versa. So I'll see you in the next section.